Video, you will learn how to calculate combinations and permutations. Let's introduce the concept by thinking of this scenario. An encyclopedia has 8 volumes. In how many ways can the 8 volumes be placed on a shelf? Does it matter which order the books are placed? Why or why not? And what do we mean by does it matter? What happens if we say no? Would you consider putting them in the order 1 through 8 being different from putting them in the order of 8 through 1? In this case, I would say yes, those are 2 different orderings of the books. Now, obviously, you might think, well, it would only make logical sense to put them in order 1 through 8. That's not really what we're asking. But is there a difference between putting them in order 1 through 8 and, say, 8 going 8, 7, 6, 5, 4, 3, 2, 1? If your answer is no, that is what we call a combination. We're just trying to factor in how many total ways are there to do this, but it does not matter in which order we are doing it. If you say yes, that is what we call a permutation, where putting them in different orders is considered a different arrangement, and therefore will have more possible outcomes. So if you're comparing the two, their permutations produces more possibilities than combinations, because we're saying 1 through 8 is different from 8 through 1. And depending on the scenario, you will see when that is or is not true. So let's look at some scenarios first and try to decide, does order matter? Yes for permutation, or no, it's a combination. A street vendor sells cashews, peanuts, and almonds. How many different ways are there to mix the 2 kinds? I would consider that a combination because it does not matter what order you list them in. Say if you tell the vendor, I want cashews and peanuts, or if you say peanuts and cashews, those are the same thing. So that's a combination. But if Karen is painting her bedroom, she's using orange, green, blue, and purple. She plans to use one color as the base coat and then stencil a design over it. How many different ways can she do this? This will make a difference because the base coat being a certain color will matter which one you put down first. So we would call that a permutation. So that's what we mean by does order matter or not. Let's take a look at a couple other examples. Allie is stringing 3 different types of beads on a bracelet. How many ways can she use 1 bead of each type to string the next 3 beads? That would be a permutation because I would consider, like, for example, if it was purple, blue, then green, to be different from green, blue, then purple. So that we would call a permutation. And Derek is ordering a sandwich with 2 of the following ingredients. How many different sandwiches can he choose? We would call that a combination because if he's ordering 2 items, it doesn't really matter what order he recites them in, he's going to get the same sandwich. Now, in order to figure out how we calculate what these number of possibilities are, combination or permutation, first you need to understand the concept of a factorial. A factorial in math, this is a new symbol, kind of like an operation symbol like multiplication, addition, division, subtraction. A factorial is an exclamation point. Okay, and you see this in math. This doesn't just mean that someone is really excited about the number 5. What it means is it's the product of all of that number and all of the natural numbers less than that number. So 5 factorial is how you would read this, which is equal to 5 times 4 times 3 times 2 times 1, which is 120. We saw this in the last example where we were looking at if I had 5 outcomes for the first thing, and then I needed to reduce that. I now have only 4 left, times 3 times 2 times 1. When we were talking about cards in the deck, if I take one out and don't replace it, that's kind of the concept of a factorial, what we're talking about. Now we need that because that is part of the formula for combinations and permutations. The way we see our problems for permutations is N, which is the total number of items, P stands for permutation, and R is how many items you're choosing. Okay, and sometimes it's all of them, sometimes it's only some of them. Let's say you have a class of 20 students, but you're only picking 5. So the number chosen might be the same as the total, but it might also be less. The formula is this: n factorial over the difference of n minus r factorial. The good news is there is a button on your calculator that will do this for you. And you might want to write this down on your notes so you know what buttons to press. To do this on your calculator instead of by hand, you're going to first type in the number that goes with your value of n. So you're going to type in your n value first. Okay, so write this down. Step 1 is to type in n. Step 2, you're going to hit the math button. And you're going to scroll over so that the top category is highlighted as PRB across the top. So that's hitting the right arrow 3 times. Then when you get there, you should look at option 2, shows NPR, like this right here. So you can hit the number 2, or you can scroll down and hit enter. And then once you hit that, you should see the NPR show up on your screen. And then you're going to now type in the value for R, and then lastly you're going to hit enter. Okay, so to give you an example, just to see how this works, and you can try that to see if you got it to work. Let's say that we have 10 total items, and it's a permutation, and we're choosing 3 of them. Take a moment to try those buttons and see if you get the same answer that I will share with you. You should have gotten 720 for that problem. Now that you know how to type that into your calculator, I'm going to show you how it works on the formula. So n factorial, that's 10 factorial. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in the denominator, it's the difference of n minus r. So in this case, that would be 10 minus 3, which is 7. And then that factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. If you look at what I have now, I have 7 times 6 times 5 times 4 times 3 times 2 times 1 that appears both in the numerator and the denominator. This entire product will cancel out this product, leaving us only with 10 options for spot number 1, 9 options for spot number 2, and 8 options for spot number 3 because I was only picking 3 things from that list of 10. Let's apply this to a word problem scenario to make sure that we understand. So for example, a club will choose a president, vice president, and a secretary from a list of 8 people. How many ways can they choose those 3 officers? So we have 8 people chosen 3 at a time. So that is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the difference of 8 minus 3 factorial, which is 5 factorial. And again, we see that the 5 factorials will cancel, leaving us with we have 8 people to choose from for the first office. Then once I choose that one person, I now only have 7 people to pick from for the second officer, and then 6 people to pick from for the third officer, which is a total of 336 possible combinations. If I use my calculator, again, you can type in 8, then go to math, go over to probability, select the permutation option, press 3, press enter, and you should get the same answer. As another example, how many different ways can 9 people line up for a picture? This is 9 people, and we're going to say, since we're lining them all up for a picture, that n and r are both 9. Okay, so what happens here is that we end up with 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 factorial, and then since the difference between them is 0, 0 factorial is not 0, believe it or not. Of course, it's 1. But what that means is we don't have anything to simplify this by because we're putting every single person into the line. So we need to just calculate all 9 people And that is a lot of possible ways. That's 362,880 ways to arrange these 9 people for a picture. Okay, now that seems like quite a lot, but remember 9 times 8 is already 72, and 72 times 7 is already 504, so that gets really big really fast. Now let's look at a combination. This formula is a little bit different. We have n factorial over still n minus r factorial, but we're also going to multiply on the denominator by r factorial. So let's try, I think we did 10 and 3 the first time. This time we'll do it again, but with a combination. So now, first let's do it on the calculator. The first thing you're going to do is press that n value, which is 10. The second thing you're going to do is hit math and scroll over to probability. Then you're going to this time choose option number 3, which is the NCR, and hit enter. Or scroll down and hit enter. And then you're going to type the R value, and then lastly, after you type the R value, hit enter. So if you do this with 10 and 3, you should get 120 combinations. Now to look at how this works mathematically so that you are understanding what the calculator is doing, let's do this all the way out here. Here's n factorial. R factorial is 3 times 2 times 1. And then n minus r factorial, that's 7 factorial. So that's 7, 6, 5, 4, 3, 2, 1. Again, that will cancel. Before, we were just left with 10 times 9 times 8. But remember, we don't want the other half of the possibilities of like reversing those combinations. So we're going to cut that divided by that r factorial, which is the number chosen, which in this case is 6, 3 times 2 times 1. So that's why we end up with less combinations than permutations, because now I'm going to take all those possibilities and basically reduce that by r factorial, because we don't care about the reverse option. So for example, like if you're putting something in order, blue, purple, green, we are considering that the same as purple, green, and blue. So we don't need that, and we also don't need green, blue, purple, green, purple, blue. So you can see it's not just like cutting it in half. It depends on how many items there are that we're picking from and ordering, how many we will cut it by or divide by. All right, so try these couple. If this case, we're forming a 3-person committee, but we're not identifying them as president, vice president, secretary. So in this case, the order does not matter. So we have 25 people in the club. 3 of them are being chosen for the committee, but we don't care we're not giving them a specific role. So if I do that with my calculator, type 25 in first, math, scroll over to probability, option 3 for the combination, and then 3 people on the committee. That's still a good number of possibilities, but that's 23,000 people or options for putting those 3 people on the committee. So what we're saying here is if we have Sam, Adrian, and Quinn on the committee, that's the same thing as choosing Adrian, Quinn, then Sam, or Adrian, Sam, then Quinn. So we don't need all of those as a possibility. We just need those 3 people. That counts for 1 possibility. If we have 11 different cereals on sale at Giant Eagle, how many different ways can a shopper select those 4 from those 11? So that's 11 is our total N value, 4 is our R value, which is 330 different ways they can pick their cereals. So for example, let's say Frosted Flakes, let's say Cheerios, let's say, Lucky Charms, and I don't know, Chex. I don't know why that's the one that came to my mind, but we don't care if they pick them in that order or not, so that would just count as 1 possibility. We don't have to rearrange it several times to find all the different orders.